Hello everybody, I am Myself. I am going to deal with the database management system of the 5th SEM BSc, in which in today's module I am going to tell about the third unit, that is the relational data model. The various complex concepts include introduction, concepts, cloud rules, concepts of keys, relational integrity, integrity rules, normalization, relational algebra, advantages of relational data algebra, limitations, relational calculus, which has tuple relational calculus and the domain relational calculus. These are the various objectives of this data model, in which in today's module we are going to learn about the introduction to the relational data model, followed by the concepts of keys, which include the various types of keys that are being used in the relational data model. So let us start our discussion with the introduction. So in the introduction, in the relational data model, we have to know first of all what is a table. The table, which means a two-dimensional structure which is composed of rows and columns. A table has rows and columns. A table in the relational data model is called as a relation. In the relational data model, a table here is called as a relation. What does a table contains? A table contains a group of related entities which is called as an entity set. A table contains information which is nothing but related to the same thing. For example, if I take the student table, what does a student table contain? It contains number of entities that is number of details about the student. Different students' information are being placed into the table group that are related to one another. So what are the characteristics of the table? So what is a table and what is its characteristics? So a table is composed of rows and columns. What does a table contain? A table has rows and columns. A table is the mathematical term, and also rows and columns are also a mathematical term. So they are renamed here as a row is called as a tuple, which denotes a single entity. A row here is called as a single entity, which means that if I consider student table, in that a single row includes student number, student name, his address, his phone number, etc. All these put together is called as a tuple, which means a single row information, which is called as an entity set. A single entity in the entity set, which contains number of students information inside it. Each column of the tables are called as attributes. Every column in the table we have number of columns. Each column here is called as an attribute, which is called as an attribute, and its name must be unique and distinct. The attribute's name should always be unique and distinct. For example, S number is one column name, followed by next one as S name, next one as S address, like that. Every column name should be unique, and these columns here are called as attributes. In general terminology, a table has rows and columns, which is a mathematical term, but in the computer science, in this data model, in the relational data model, the table is called as a relation, and the rows here are called as the tuples and the columns are called as attributes. Now, the place where a row and a column meet is called as a cell, wherein which we hold a single data value. The place where a row and column meet is called as a cell, and there that is the place where we enter or where it holds a single data. For example, S number includes 1, 2, 3, etc. like that. All the values of the columns must be of same data format. So if I consider the column S number, it should always, the name itself specifies S numbers. In that column, I need to enter the value which is a numeric data type. In the similar way, S name, which tells us that that column will hold the values which belongs to the character variables. Like that, we have to enter the values which are of the same data type. The column name, yes name includes, we should enter the values into the columns which have all the name values, new character variables. In the similar way, each column has a specific value, specific range of values known as domain. For every column, I can define a range of values which is known as attribute domains. That is, for every attribute, I can define a domain, which means if I consider gender, if I consider a column naming student gender, in that there is a range of values, which means I can either pick out a male or a female, in which I have two options available, which is nothing but a range of values, that is here called as a domain. That is called as a domain. That is nothing but a range of values out of which I need to specify one particular. If I am going to enter my name, the gender will be female. If I enter Rama as a name, the gender will be male. Like that, I need to enter one among the existing values. That existing values range is here called as a domain. Domain is nothing but the range of values. And the other thing is that the order of rows and columns is immaterial. The order of entering the rows and columns, you can put yes number followed by yes name, after that etc., after that yes gender, like that. You can define the columns as you wish. Also, you can enter the values into the table as you wish. You can enter 1 to n number of rows into the column. The table generally contains one attribute which is called as a primary key attribute. For every table, we should always definitely define one attribute. Compulsorily, we have to define one attribute. That is, for one column, definitely I should define one primary key. What is that primary key? A primary key is an attribute that uniquely identifies the rows of the table. Let us now discuss about these things later in detail. A primary key is an attribute that uniquely identifies the rows of the table. Every row of the table is being identified with its primary key. Once if I define for a primary key in a table, with that primary key I can know all the things of the table. With that primary key I can find out everything what I require from the table. So what is this primary key? That is what we are going to learn here in the various types of keys and discussing about the various types of keys. In the relational model, keys are important as they help us to identify each row of the table uniquely. So these keys helps us to identify everything from the table uniquely without any duplication. We can identify them easily with the help of the keys. Also with the help of keys, we also provide data integrity. That is, security is also being provided to the data of the tables with the help of these keys. A key can be defined for one or more attributes in the table. A key can be defined either for one column or one or more columns, with the help of which we can find out the other attributes. So with that key, I can get out the other attributes of the table. About these 3 points, we will discuss in detail in the various types of keys. The various types of keys include primary key, composite key, super key, candidate key, secondary key, and foreign key. Let us now discuss about these various types of keys in detail. Coming to the first one, primary key. The most important key, as the name itself specifies, primary means which is very, very important. So primary key, as a rule, in the relational data model, it is defined as a rule that every table should definitely contain a key which is called as a primary key. So what does a primary key do? A primary key is a key that uniquely identifies each row of the table. In order to identify every row of the table, we have to definitely define the primary key of the table. Let us tell me again. Primary key. A primary key is a key that uniquely identifies each row of the table. In order to identify every row of the table, I need to define a primary key. Let me demonstrate it with an example. Consider an example student table in which yes number is the student number which is being defined as the primary key. In the student table, I am going to consider yes number which is defined as the primary key. Why should I define that as a primary key? Because with the help of the test number, we can determine other attributes of the table. That is, other columns. Attributes are nothing but the columns. With the help of yes number, I can determine other attributes of the table easily, which include, with the help of yes number, I can find out yes F name, yes L name, yes initial, yes date of birth, yes email, yes address, etc. Yes first name. F name means student first name, student last name, student initial, student date of birth, student email, student address. If I know the student number, with the help of that student number, I can find out all the other attributes. The other attributes include first name, last name, initial, date of birth, email, etc. Like that, if once I define yes number as the primary key, with that yes number, I can get all the details of the student. One important thing here to remember is that yes number will help us to find out yes last name. With the help of yes number, I can find out yes last name. But with yes last name, I cannot determine yes number. Because in yes last name, if I consider as in yes last name, if I consider some Sastri, Sarmal like that, there can be such names which can be repeated, or Reddy, Chaudhary. For some students, they will be writing their last names as these things, which can be repeated for more than one student. Coming to yes number, it is always being identified uniquely. It is being always identified uniquely because the student number 1 is not being repeated again. Number 1, if it is defined for one particular student, that number is not being repeated again. if it is being repeated, then that column should not be defined as the primary key, because the basic rule of the primary key is that that particular attribute or that particular column should always maintain unique values. Each row of the table must be uniquely identified. Such column must only be defined as the primary key. So coming back again, with the help of yes number, I can find out all the other attributes of the table, and this concept is called as functional dependency. What is the name of this concept? This concept is called as functional dependency. Now the definition. The term functional dependency can be defined as the attribute B is functionally dependent on the attribute A. That is, A determines B. That means with the help of A, I can find out B. With the help of A, I can find out B, which can be represented as A arrow B. A arrow B, which means that with the help of A, I can find out B, which means that B is always dependent on A. B is always dependent on A. Example, yes number. With the help of yes number, I can find out yes last name, yes first name, yes initial, date of birth, email, etc. With the help of yes number, I can find all these things. In the relational database, the representation with relational schema is as follows. This is represented like this. Student, it is a table name followed by a parenthesis, by a set of parentheses, in which yes number is called as the key attribute or the primary key, which is being underlined, followed by the other attributes which are first name, last name, initial, etc. Within the table, each primary key is unique, so that each row is being identified uniquely. So in the table, all yes numbers, because it is a primary key, it will be unique, and they can be, with the help of that column, I can be identify the other attributes. In this case, the table, if we are able to maintain the table like that, then that table is said to be maintaining entity integrity. Then that table is said to be maintaining entity integrity. So about this entity integrity, we'll discuss in detail in the next slides. So to maintain entity, in order to maintain entity integrity like this in the table, we should remember the following things. To maintain entity integrity, null values are not allowed into the primary key. So null values should not be defined in the primary key. If suppose I define yes number as a primary key, in that I should not forget to enter a value into that, but S number, if it is defined as a primary key, all the S number values should be filled. They should not be left empty. At the same time, it should also be unique. All the S number values should be unique. They should not be repeated again. Nulls represent, what is a null? A null represents an unknown attribute value. If we do not write any value, that is an empty place, or an missing attribute value if we forget to write anything, or an not applicable condition. If we are not able to write anything over there, it is called as a not applicable conditions. So what does a null represents? An empty value, or if we forget a value to write, or there is no value to be written. Such things are called as null values. Now coming back, that is about the primary key. The next thing to be discussed is about the composite key, which is also called as the composite primary key. What is a composite primary key? So it might take more than one attribute to define functional dependency. At times, if we are not able to define only one column as a primary key, then we need to take a combination of two or more attributes to define primary key. That is, a key may be composed of more than one attribute. If more than one attribute is being combined to define a primary key, then it is called as a composite primary key. Such a multi-valued attribute is called as a composite primary key. So if we take more than one attribute, it is called as a multi-valued attribute kabatti alanti multi-valued attribute ni we call it as a composite primary key. For example, in the student table, yes last name cannot be defined as a primary key. Yes last name alone cannot be defined as a primary key. As I already told, Sastri, Sharma, Reddy, Chaudhary, like these names can be repeated for n number of students. So that alone cannot be defined as a primary key. So what do I do now? I combine another attribute with that. What do I combine? In the example, look down. Yes last name, yes first name, yes initial. These three put together, I combine these both and I define the primary key. yes last name, yes first name and initial. All these three attributes put together, I define a key which is called as a composite primary key, wherein which here there are more than one attribute. Here I am going to combine two or more attributes. It can be 2, it can be 3, or depending upon the requirement of the user. Here I am considering 3 attributes together as a composite primary key, with the help of which I can determine yes date of birth, yes email, yes address, etc. Such things. Now we can define the functional. For this, the functional dependency can be defined as the attribute B is functionally dependent on A. The attribute B is dependent on A, but not on the subset of the composite key. But not on the subset of the composite key. That is, the attribute B is fully dependent on A. It is not dependent on single attribute. It is dependent on all the 3 attributes. All the 3 attributes in A will help us to determine B, not a single attribute. That is what is about the composite key, followed by the next one as the super key. What is a super key? A super key is a key that uniquely identifies each row of the table. Every row of the table is being uniquely identified with the help of this key, which is called as a super key. Now, what is the thing? What is the thing that is being used? Which column can be defined as a super key? An attribute or a combination of attributes that uniquely identifies each row of the table can be defined as a super key. So, one attribute it can be defined as a super key, or a combination of 2 or more attributes can be defined as a super key. Super key is a key with or without additional attributes. Single attribute can be defined as a super key, or more than 2 attributes combined together, it can be defined as a super key. Super key is functionally determines all the row attributes. With the help of super key, I can determine all the attributes of the table. In the student table, super key can be any one of the, if I consider the student table, we can define any one of these as the super key. What are those? Either yes number alone can be defined as a super key, or yes number along with yes last name, first name and initial. All these 4 put together can be defined as a super key, or yes number and yes last name alone can be defined as a super key. Like that, with the help of one attribute I can define super key. With the help of more than one attribute also I can define the super key. Yes number with or without additional attributes can be defined as a super key. Now the next key to be discussed is about the secondary key. What is a secondary key? A secondary key is a key that is being used only for data retrieval purpose. That is to get the data. Retrieving means to get the information. If I ask you something, that information, if I get it, that is called as retrieving of data. Secondary key is a key that is generally used for data retrieval purpose. In the student table, yes number is a primary key. So yes number can be or is alone sufficient to get all the details of the student. So such key can be defined as such a column can be defined as a secondary key. Data retrieval for the students can be facilitated with the help of, also we can retrieve the data of the students with the help of S last name as well as yes first name. Yes last name and yes first name also can be used to get the details, get all the other details of the student also. Like that, yes last name and yes first name can also be defined as a secondary key. The secondary key is again is a combination of student last name and student first name. An attribute or a combination of attribute that is strictly used for data retrieval, and this secondary key is specially defined only to retrieve the data. If we use the data, if we use this key to get the data, then if we use any key to get the data, if we use any column to retrieve the data, that key is called as, or that particular column is called as a secondary. That particular column can be defined as a secondary key. That is about the secondary key, followed by the next one as candidate key. What is a candidate key? A candidate key is nothing but a super key without unnecessary attributes. That is, it should not have any additional attributes. If we do not have any additional attributes, and if we define only one column as a, for one column only, if we define that particular column as a candidate key, then it is called as a candidate. That is, if we do not have any additional attributes, then it is called as a candidate. That is why it is also called as a minimal super key. That is called as minimal super key, because a super key can be defined for a single column or more than one column. If we define the super key only for one column, then it is also called as a candidate key. A super key does not contain the subset of attributes, is a super key. It should not contain a super key. A candidate key should not contain a subset of attributes. It should contain only one column, or we should define only one column as the candidate key. This is about the candidate key. A primary key is a super key. A primary key, it can be a super key as well as it can also be a candidate key, because a primary key is defined only for one column. In super key also I can define a super key is also defined only for one column. Also a candidate key is defined for one column. So a primary key, it can be defined as a super key. If required, it also can be defined as a candidate key. A primary key is a candidate key chosen to be unique row identifier. So this primary key is also called as a unique row identifier, because with the help of this only I can calculate the other attributes of the table. Now the last one to be discussed in the keys, and the most important key to be discussed after the primary key, is the foreign key. Discussed in the keys is about the foreign key. So what is a foreign key? So what is a foreign key? Tables in the database share an attribute that enables a table to be linked with the other table. In order to establish a relation in between the tables, so in order to establish a link or an association in between the tables, we need to combine one table with the another table. That is, we need to use the table the contents of one table into the another table. We need to use the contents of one table into the another table. For example, consider the relation between product and vendor. Here I am going to consider two tables, vendor table and the product table, in which in the vendor table I am going to have the attributes as vendor code, vendor name and vendor agent code. In the product table I am going to use the attributes as product code, product name, product price. And look over here, the vendor code from the vendor table is being used here as the foreign key. This foreign key is being used to establish a link in between the vendor and the product table. The primary key of the vendor table is being used into the product table. Then if we use it like that, in the product table, the vendor code becomes the foreign key, because it is being brought from the first table. In the first table, I have vendor code, which is being used by me into the second table. If I bring table 1 contents into the second table, then it is called as a foreign key. That way of retrieving the information from first table into the second table, it is being obtained with the help of the foreign key, which is being used to establish a relation in between both the tables. So the primary key of the table vendor appears as a foreign key in the related table product. So the primary key in the vendor table, that is vendor code, it is being used into the product table as a foreign key. The foreign key is an attribute whose value match with the primary key of the related table. More about this we'll discuss with an example in the further slides. In the vendor table, the vendor code acts as a primary key. It acts as a foreign key in the product table. In the vendor table, vendor code is the primary key, wherein which it becomes a foreign key in the product table. If a foreign key contains either a matching value or a null value, the table makes use of the foreign keys is said to be maintaining differential integrity. About this also, these 2 points also we'll discuss in detail about in the integrity rules. We'll be getting a deep discussion about this differential integrity, and so then we will discuss. The differential integrity means that if the foreign key contains a value, that value refers to the existing tuple in another relation. That value is obtained from another table. That means that in the foreign key we have values which are being obtained from another relation or another table. The product table and the vendor tables are as follows. So consider the product table and vendor table. Here, if we look over here, the first one is a product table and the second one is a vendor table. From the product table, from the vendor table, I am going to retrieve it into the product table. The vendor numbers, if we look over the vendor numbers, it is 230, 231, 232, 33, 34 and 35. These vendor numbers are being used again here in the product table. See, 232, 235, 231, 232, 235. All these numbers, these are called as, in the product table, vendor code is called as a foreign key. In the foreign key, we have the values which are being obtained from the vendor table. In the vendor table, I have the numbers ranging from 230 to 235, whose numbers are being used here in our product table. Those numbers, only we should use these numbers. Non-existing numbers should not be used. That if we are able to use the numbers like that, then that table is said to be, that is the product table is said to be maintaining differential integrity. That is called as differential integrity. What does the differential integrity means? The primary key values used here, they should be only used in the foreign key. The values used in the primary key, they should be only used in the foreign key. New values are not allowed here into the foreign key. If new values are allowed, we can write new values. If we write the new values here, then what happens? Then the table fails to maintain differential integrity. Then the table is said to be lacking of maintenance of differential integrity. That is the diagram, and this is the module summary in which we have discussed about the introduction, followed the various types of keys. Hope you followed and understood. Thank you all.